Question number 5, like I said at the beginning, your analytical geometry is going to be about 37 marks. That's quite a bit. It's more than the stats. And the analytical geometry question that I want to focus on last year's paper is question number 5. Can we go to question number 5 now? And I want us to look at this question carefully. And it said, in the diagram below, A, which is 3,7, B, which is 1 and -6, and C are the vertices of a triangle. And AC is extended to cut the x-axis at D. Okay, so look at your diagram quickly with me. You've got A, B, and C. You've got your coordinates, and AC cuts the x-axis at D. The very first question that they asked us there, and I am going to do this with you, they ask you to find the gradient of AD, and then you must go and find the gradient of BC. I'm going to put that there so that I can just show you. I need to go and find the gradient of AD. Now everybody knows I'm going to write down my formula first. The gradient of AD is y2 minus y1 over x2 minus x1. That's my gradient formula. But what went wrong in this question is people wanted to have coordinates for D. They didn't see coordinates for D, and then they didn't know how to work out the gradient. Remember, if I must find the gradient of AD, I don't need to have D. I can have any 2 points on the line. Now, I have point A, which is 3,7, and I have point C, which is -3 and 4. Remember, I said I can use A and I can use C to find the gradient of AD. Ek markeer nie die koördinate van D om die gradiënt te gaan bepaal nie. Luister na my baie mooi. Jy hoef nie D te hê nie. Jy kan net A en C gebruik. So ek gaan sê 7 minus 4, 7 minus 4 divided by 3, and here comes the mistake everybody makes. You see the -3, now you write negative. But there's already a negative in your formula. So you go and you do that. If you want to go directly to +3, that's fine. 7 minus 3 gives me 3 over 3. A negative times a negative is a positive, so 3 plus 3 gives me 6. And the gradient of AD was a half. Gradient of AD is a half. We're ready to work out the next gradient. Please, everybody, again, big mistake. You don't need the coordinates of D to find the gradient of AD. You can use any 2 lines, any 2 points on that line. You don't need D. You can use any 2 points on that line. Okay, now the gradient of BC was very easy. I'm not going to do the gradient of BC with you. The gradient of BC was equal to 2. So what do I have so far? I have the gradient of AD, which is equal to a half. And then I have the gradient of BC, which you worked out. You can work that out on your own. You can sit with a friend and just compare quickly. y2 minus y1, it's the gradient of BC. y2 minus y1, minus 6, minus 4, 1 plus 3. And if you worked it out correctly, and I'm sure you can all do this, this is just a routine question. Everybody can work out the gradient. It's -5 over 2. And do you know, just for working that out, you can score 2 marks for the gradient of AD and then 1 mark there for the gradient of BC. Now comes the difficult question. Let's see. The question that lots of pupils battle with in analytical geometry, they asked us to go and find this angle here. Go and determine the angle DCB. DCB is this angle here. I have to go work out DCB, angle DCB. Now, in analytical geometry, everybody, when you are finding an angle, tell yourself, I am working with this formula, tan theta is equal to M I'm working with the formula tan theta is equal to m. So I am working with gradients. So if I must find that angle there. Remember, what is an angle of inclination? An angle of inclination is an angle measured, listen very carefully, from the x-axis in an anti-clockwise direction onto that line. So I can go work out this angle here. Let's call this angle alpha. Why can I work out that angle? It's an angle of inclination and I have that gradient. And then the other angle that I can go work out, remember you just worked out the gradient of BC. I just found the gradient of BC, so I can go and find from the x-axis, anti-clockwise direction, I can go work out this angle here. Let's call that angle theta. Now listen very carefully, that is what you're going to start with. I want to go and find first this angle alpha. So to find angle alpha, I am going to say, just look, I'm going to keep my finger on alpha and watch what we're going to do. We're going to say the tan of alpha is equal to the gradient. Learners, what gradient are we talking about? Gradient of AD. Because it's negative, it's in an anti-clockwise direction onto that line. I need the gradient of AD. We worked it out. What was the gradient of AD? You can tell me before I can even tell you. The gradient of AD was a half. I still have it here. The gradient of AD was a half. Now you need to go to your calculator now. And what we're going to do is, you're looking for an angle. So it's second function tan of a half. And that gives you, that angle there was equal to 26,57 degrees. Alpha is 26,57 degrees. That's that angle there. I'm even going to make a little arrow for you. I've got that angle. I'm getting close. I've got that angle. What is my objective in the sum now again? What is my goal? I want to find this angle here. So ready, I can now find theta. Again, why can I find theta? Because I have the gradient of BC. I know what BC is. So I can go and find that angle. So I am going to say the tan of theta is equal to the gradient. Let me write here. This is the gradient of AD there. So this will be the gradient of BC. So tan theta is equal to, what's the gradient of BC? We just worked it out, -5/2. That's the gradient of BC. Learners, please look at this. This is important. Something different. Theta is going to be 180 degrees minus. Why did I not have 180 degrees here? 180 degrees minus, because this gradient is positive. This is a positive gradient. This is a negative gradient. If you have a negative gradient, grade 12, please listen. A negative gradient, then you have to say 180 minus. Again, go to your calculator. You say second function tan of 5/2. Shift tan 5/2. I get an angle of 68,19. Or we can say 68,20. Correct to 2 decimal places. 68,20. And you're going to subtract that. So it's 180 minus that 68.2, and we get an answer of 111,8. $111,80. Okay, so that is that angle there. Great. Learners, just listen very carefully. I didn't punch in this negative when I found this angle. I only said 180 degrees minus, and I said second function tan of 5 over 2. You don't punch in that negative because you're compensating for the negative here by saying 180 minus 68,2. So this angle here is now equal to, and I'm going to bring it nicely for you to see, this angle here is now 118,2. And now you can find the angle that was asked is this angle here. So this exterior angle, this is the exterior angle of your triangle, is this one plus this one here. This angle is this one plus this one. So you are going to say that angle, this angle DCB that they asked me, angle DCB is equal to, you have 118,2 minus 26,57. 118,2 minus 26.57, and they get an answer of that 111. Sorry, this was 111. I made a mistake there. 111,8. 111,8 minus 26,57. Teachers also makes mistakes, everybody. 111,8. Everybody still remembers. Minus 26,57. Forget that. I'm just going to write it again. 111,8 minus 26,57. And your final answer must be 85. 111.8 minus 26.57. And you get an answer there of 111. Let me just punch this in correctly. Minus 26.57. I think you get it before me. There we have it. 85,2 degrees. At last, we have the angle DCB. 85,2. Remember, I made a mistake. I had to write 111 and I wrote 118. You make these mistakes sometimes. You're in a rush in the exam. You're worried. You're nervous. I made a mistake there, not because I'm nervous. I love teaching you mathematics is my passion. So it's 111,8 minus 26,57, and we got an angle of 85,2. And that was question number 5.2. It was lovely showing you that some angle of inclination is always in an analytical geometry paper. The next question was to go and find the equation of the straight line AD. Very well answered by students. I'm not going to do it. I'm not going to take too long with it because it's not so difficult to find the equation of line AD. I just want to show you something quickly. You have y equal to mx plus c. Do you have your gradient? Of course. I have the gradient of AD. We worked out the gradient of AD to be a half. And I think everybody knows what to do after this. You substitute any point on this line into this equation. I'll take the 3 and the 7. And there you have it. Your equation for AD. You just substitute a point there and you work that out. And we got that the equation of AD was equal to y equal to a half of x. Where does the half come from now again? It is my gradient. And after I substituted my points, 3 into the place of x, 7 into the place of y, you find that c comes out to be, c was equal to 11 over 2. Or you can say 5 over half. 5 and a half, half of x plus 11 over 2. That was the equation of line AD. We substituted a point, got that, and everybody, that is a very easy question. Also something asked quite frequently. Write down, determine the coordinates of M the midpoint of BC. If you can't see so clearly on the screen, it doesn't matter because I am going to just read the question to you as well. Determine the coordinates of M, the midpoint of BC. Everybody answered this question correctly in the exam. Everybody got it last year. The midpoint there, 5.4, was -1 and -1. Go to your formula sheet. You get the midpoint on the formula sheet. You punch your values in and you have it. Very simple. Everybody got these 2 marks. They scored these 2 marks. They knew exactly what to do. That was the midpoint. And now we come to a question that I think we must look at very carefully. These are the questions. The next question that I'm going to deal with you is a question where it is not straightforward. You don't just read a formula from the formula sheet, put it on your sheet and punch in values or enter in values or substitute. If we look at the question closely, I'm going to go through this question with you and I hope that after I've explained it, you will understand it. It is question number 5.5. Question number 5.5 said, if G, which is A comma B, now there's my A comma B. If G, which is A comma B, is a point such that AGM lies on the same straight line. AGM lies on the same straight line. I have to go and show that B is equal to 2A plus 1. So what I'm going to do now is, I just want to draw the straight line in for you guys. You can also do it. There's my straight line. And I have to say, I have to go and show that B is equal to 2A plus 1. If a point lies, if there are points that lie on the same straight line, what do we know? We know that the gradients are the same. Now I'm now going to write down the coordinates of A is 3 and 7. G is A and B. And then I have M. Where did we get M from now again? M was my midpoint. -1 and -1. They all lie on the same straight line. If points lie on the same straight line, their gradients are the same. Remember that. What's that word that we use now again? Collinear. The points lie on the same straight line, so it's collinear. So watch what I do. Remember, what must I prove? I have to prove that B is equal to 2A plus 1. This is my goal. This is my objective. My father always asks me, Eleanor, what is your objective? What is your goal? My goal is to show that B is equal to 2A plus 1. What is your goal? To show that B is equal to 2A plus 1. These points lie on the same line, so the gradients are the same. The gradients are equal. What is that concept? Collinear. So I'm going to start. Just look what I do, students. The gradient of AG is equal to the gradient of GM. Why am I writing this down? Why am I writing this down? Because they are collinear. Because they are collinear. I'm ready to substitute now. Remember, your substitution is y2 minus y1 over x2 minus x1. So I have, just follow me closely, I'm first going to work out the gradient of AG. So it is B minus 7 over A minus 3. You can fill it in by yourself. And GM, negative 1, negative B over negative 1, negative A. What did I do? I equated my gradients. I put them equal to each other because they told me they lie on the same straight line. All I'm going to do now is I'm going to cross multiply B minus 7 times that. So you can do it with me. B minus 7 times negative 1, negative A is equal to A minus 3 multiplied by negative 1, negative B. I'm going to multiply out. We're going to FOIL. Everybody, I hope you're still with me. Just remember, what is my goal? To show that b is equal to 2a plus 1. Got a gradient of AG is equal to the gradient of GM. Okay, now FOIL with me. Work with me. B times -1 is negative b. Then I have b times negative a is negative AB. Negative 7 times 1 is positive 7. And negative 7 times negative a is positive 7a. Equals, I'm on the right hand side now, a times negative 1 is negative a. Then I have a times negative b is negative ab. And then I have negative 3 times negative 1 is a positive 3. And negative 3 times negative b is positive 3b. I'm sure you got that. All I did was I multiplied out my gradient, my brackets, and now I'm ready to see. Oh my goodness, I must try and get to b equal to 2a plus 1. Okay, so let's see. Maybe I can bring this, if I bring this negative ab across to this side, your ab's cancel. Oh, that's very good. My ab's cancel. I need a b, so I'm going to take my negative b over to that side. Then I have 3b. If I bring that negative over, it's plus b. Remember, your ab's cancel. I forgot about that. That's out. I'm not going to put it into my equation. On this side, I have 7a. Bring that negative a across. It gives me 8a. And if I bring the plus 3 across, 7 minus 3 is plus 4. I'm getting there. We're almost at the end of this sum, and I bet you think it isn't so difficult like it seemed. What is 3b plus b? It's 4b. Now I just need to get b. So I'm going to divide by 4 on both sides. 4 goes into 4 once. There's my b. If I divide the 4 into the 8a, I get 2a. And the 4 into the 4 gives me 1. Smiley face. We did it. We got it. B is equal to 2a plus 1. You've reached your goal. You've reached your objective. You scored a full 4 marks there. That's quite a lot. B is equal to 2a plus 1. And learners, that was question number 5. Not so difficult. Not so difficult at all. Collinear, put your gradients equal to one another.